a vital clue arrived on the 18th of January, 2000. That evening, the sky above Western Canada lit up with a bright light. Dozens of witnesses saw a meteorite enter the Earth's atmosphere. Seconds after the event, local photographers took these pictures of the trail it left in the sky. As it fell to Earth, the meteor broke up into dozens of pieces and landed on Tagish Lake in British Columbia. Within days, scientists were on the scene extracting the frozen remains. The pieces they pulled from the ice were the best preserved meteorites ever recovered. Still intact, a piece was shipped to NASA's laboratories at the Johnson Space Center in Houston. Here it was examined by space scientist Michael Zelensky. The meteorite was remarkably undamaged, despite heating up through friction as it entered the Earth's atmosphere.
The meteorites, they're cold-soaked in space for millions of years. So they're very, very cold. And they enter the atmosphere at high velocity, and they do, in fact, get very hot on the outside. But they're only heated for a few seconds. And that's not long enough for the heat to get all the way in, past a few millimeters, actually.
This means that when meteorites hit the ground, they cool very quickly.
You hear of reports of meteorites causing fires on the ground, things like that. That's always wrong. They're actually quite cold to the touch after a few seconds.
But when a meteorite is fragile, like the one at Tagish Lake, where it lands makes all the difference.
Very lucky it fell in a frozen lake. If it had fallen anywhere else, it would have easily fallen apart to dust in a few days. And so it's quite possible this kind of meteorite falls to Earth very, very commonly. It's just usually destroyed.
Because the inside of the meteorite remained frozen, Zelensky was able to analyze what it was made of.
This is a sample of the Tagish Lake meteorite. The black material here is mostly clay minerals, the kind that you'd find in your yard, and these clay minerals contain water molecules trapped inside. And so about 20% of this meteorite by weight is water. That's a huge amount.
From the location and angle at which the meteorite fell, astronomers were able to trace its orbit back into space. They discovered that it came from the outer reaches of the asteroid belt.
If you do telescopic observations of asteroids, what you find is, as you move farther and farther from the sun, the asteroids have more and more water.
Astronomers now suspect that asteroids from this outer part of the belt brought water to Earth. If they're right, our oceans came from space in a torrential shower of meteorites. But one question remains. What could have caused so many asteroids to swing out of their orbit and come crashing to Earth? The culprit appears to be the biggest planet in the solar system. Jupiter lies just beyond the asteroid belt, and its mass is so great that its gravity disrupts the path of any object it comes near. In the distant past, it pulled thousands of asteroids out of their normal circular orbits into elliptical orbits that crossed the path of the Earth. When that happened, collisions were inevitable. The Earth was bombarded. As the asteroids crashed to Earth, they smashed apart, and the water inside them escaped. Explosion by explosion, they created the oceans we see today.